Hello, I'm Peter Ford. I'm the network architect for the Windows and Networking Communications group inside of the operating system group. And I'm going to talk to you today about the Windows 2000 networking and communication features. This will be a broad overview. We'll do a little bit of technical drill down per section, but you'll have to look at other talks to get a little bit more detail moving forward. The objective for today is to essentially teach you about the new networking and communications functionality that we've built into Windows 2000, and also I'd like to, throughout the course of the talk, position Windows 2000 in the networking environments that our customers are going to put Windows 2000 into. The current state of affairs today is that the internet has won. 5-6 years ago, there used to be a lot of other protocols, most of them proprietary, things like IPX from Novell and SNA from IBM and DECnet from DEC. The internet has actually blossomed. Almost all the enterprise customers are beginning to put in IP backbones and are basically driving towards standardization of IP and web-based protocols. The other thing is that all of our customers are facing the problem of scale. They're either facing that in terms of ISPs dealing with a large number of PCN systems, or they're dealing with it in the terms of customers trying to build very large clusters, very high-speed data paths between their machines. There's a lot more bandwidth. The total number of users in most environments, all the users inside of an enterprise now have a PC on their desktop. And people are running a lot of networked applications, especially challenging applications like NetShow, NetMeeting, that not only require large amounts of bandwidth, but they require the bandwidth in a very reliable, time-synchronous manner. The good news is that this is sort of the golden age of networking. Windows 2000 was designed to be a networking platform, and we basically have built a lot of new functionality into the platform to make it fit into what our customers will need to build new next generation applications. What are the issues that our customers face? Well, one of them is that with earlier products, they were much too difficult to configure and to use, and what that meant is that only a limited subset of people could actually successfully deploy applications, and a limited subset of the users could get things going. This is essentially a cost of ownership issue for businesses, and it's a barrier to entry for, let's say, a lot of home users, think people like my mom or my grandmother. A lot of the network infrastructure, both in terms of applications and also in terms of servers and also in terms of routed infrastructure, are actually way too complex and inflexible to get new applications out there on the network. We commonly have heard of customers who have 40, 50, 60 applications more that they'd like to deploy on their networks, but because of the difficulty of doing so, they're limited in their ability to get them deployed. The other major contributor to cost in a lot of networked organizations is the fact that they are running essentially 1, 2, maybe 3 networks on top of the telephone network that they already have installed in their installation. This actually contributes a lot to the cost structure, not only in terms of capital cost, in terms of equipment, but also in terms of recurring costs or operational costs, in terms of additional staff, in terms of additional maintenance costs for the equipment out there. And what people are looking at, and in the years 1999 and 2000, you're going to hear a lot of buzz about VoIP, VoIP, the ability to carry voice over IP-based networks and infrastructure. And Windows 2000 was designed with that kind of convergence in mind. Also, the one thing that we really heard very loud from our customers is because they're connecting their networks to the internet and because they're trying to do business-to-business transactions with their business partners, this whole area of security has become a major concern for our customers. And that's been reflected in new feature and functionality that we've built, not only the operating system, and you've seen a lot of that in terms of Kerberos and public key infrastructure, the things that we're doing in the Active Directory, but how do we leverage some of those new security technologies in the areas of networking? And we'll demonstrate some of that today as well. This is a picture that illustrates sort of the world that we see going forward in terms of corporate deployments and also in terms of the way the internet will be shaped. The cloud in the center represents the emerging converged network where people perform voice, they perform movies, they do other things on the network, and so they're going to want a quality of service in their networks. At the same time, you're seeing an emergence of a technology that's been around for several years but not in wide-scale deployment, and that is multicast, which is the ability for one system to generate output as a source and have many systems out there on the network collect that information. For example, a NetShow broadcast. There are a whole set of services in a classic enterprise deployment that our customers have to successfully provide services to their customers. Those are things like DHCP services, Active Directory, security, Radius for network access, remote access, DNS services, so the namespace is coupled to the internet, VPN services, quality of service services. The square rectangles essentially represent the kinds of gateway technologies. There are actually two very large networks out there. We have the PSTN, the Public Switch Telephone Network, which represents today about 650 million end systems in the form of telephones, and not to forget cell phones, which are growing at a tremendous rate. And the other great network is the internet. And as we said, there's this convergence going on. Inside of enterprise, they're going to look at trying to drive those two services onto the same wire and equipment infrastructure. The PSTN and the internet are actually layered on top of the same transmission infrastructure, but the equipment that you connect to is separate, and so we've represented this as two separate clouds. There's going to be an opportunity for interesting gateway technology based on NT and other people's equipment that will actually allow you to talk to both the internet and the PSTN from the corporate network. And we've seen a lot of activity at things like CTI Expo and other shows where people are taking the power of NT and actually building these gateway technologies between these two networks. This is an overview of the network architecture that we have in Windows 2000 and gives you sort of the layer cake approach. It's not quite a 7-layer network, but it essentially represents the way the structure of our system works. The lowest layer is essentially divided by this NDIS 5.0 layer. NDIS is essentially an interface that allows hardware vendors and software vendors to integrate into the bottom of the system so that we provide value to, let's say, having different kinds of NICs or modems or ATM adapters plugged into the bottom of Windows. In the middle layer, we have the protocol layers. The dominant protocol 10, 15 years ago was NetBEUI. That transitioned to IPX, and now you can see that the TCP/IP layer is the dominant layer, and in fact we've added a lot of new functionality in that layer. Specifically, we've added things like quality of service represented by the classifier and scheduler. We've added security features such as filtering and IPsec, which stands for IP security. And then we've added functionality in terms of the IP forwarder, which is essentially a routing sublayer in the TCP/IP subsystem that allows people to build branch office routing, SOHO LAN routers, functionality and firewall functionality into an NT-based platform. Above that layer, the line that divides the middle layer and the top layer is called WinSock, which is a programming API layer, and it's also, there are some other APIs that are there. For example, the IP helper APIs, the IP filtering APIs, the IP router steelhead APIs. We also have things like the TAPI API, which is the telephony API, and there are APIs that are used by subsystems like DirectShow, which provide media streaming. And we not only can do media streaming within the system, for example, a DVD playing video out onto your VGA screen, but we can also take streaming media off the network and then run it through the DShow system. So the network is now interfaced into the DShow system in Windows 2000. In terms of the three major areas that we tried to attack when we sat down in actually now 1996 was that we wanted to simplify networking. We wanted to generate a great set of APIs so that people could program new functionality on top of the platform. And we also wanted to enhance the platform with new capabilities so that people would find the platform attractive and build on top of it. To that end, we wanted to make it easy for end users and the administrators, so we were trying to simplify the UI that you see on the desktop, and we also wanted to make the management subsystem attractive to network admins. So one of the other major pieces of functionality that's throughout the Windows 2000 platform is we have plug-and-play capability, which is new to the NT-based platforms, and we also have extensive new capabilities in the form of power management. The third sub-bullet here is really to attack the Windows 2000 professional on laptop markets. In terms of programmable network infrastructure, the things that we envisioned for that were things like firewalls, small SOHO LAN type routers that interconnect, let's say, a branch office to the internet, and then subsequently to headquarters. This included functionality like, a primitive routing capability, and also the ability to have what is commonly called policy-enabled networking, and often called directory-enabled networking, where essentially the administrators are able to state what kind of activity they expect to have on their network, and if somebody tries to violate those constraints, they're prohibited and they're appropriately notified that they can't have that kind of access to the network. In terms of enhancements of the platform, a gigantic area that we had to attack in Windows 2000 was the whole area of performance, and we've significantly improved the performance of the TCP/IP stack in anticipation of large N-way machines, so servers that have more than one processor, and also the fact that people now commonly have 100 megabit adapters in their desktop and in their laptops, and they have gigabit adapters or multi-gigabit adapters in their servers. Also, the whole area of network security is very important in terms of how do you prevent people from spoofing, how do you prevent people from capturing data that they shouldn't have, how do you encrypt traffic on the network so that people can't snoop the wire and see what's going on. Network quality of service addresses the issue of being able to present two pieces of new functionality. One of them is that network administrators depend on the network to provide reliable service for applications like Exchange or SAP or other mission critical applications. And so the network administrators want to make sure that the traffic that they feel is important is better handled by the network than, let's say, casual browsing of the web or people goofing off on the network playing Doom or something like that. The second functionality that quality of service is intended to address is the whole area of streaming media. In other words, streaming audio or streaming video, where people are going to be able to converge things like telephony on top of a LAN-based infrastructure, and they're also going to be able to play movies, if you will. Probably not entertainment on top of the corporate network, but more things like training videos and other types of presentations. For example, the one that I'm putting together for you today. We have Endus as a layer in the system that we've improved to add connection-oriented media. This is to take advantage of new media like ATM, which the carriers are eager to deploy, and also that we are beginning to see in broadband deployment to residential networks. In terms of telephony, we've added new APIs that are COM-based, which allow people to build a new generation of applications that merge legacy telephony, POTS, plain old telephony service, and this new world of voice over IP networks. And we've done that under the TAPI 3.0 API structure. And the other thing is that glue that we've presented that glues together the direct show audio video subsystems with codecs and digital signal processing capabilities and compression technologies with actual network layer functionality, for example, bridging RTP into the D-show environments. We're going to drill a little bit down on each one of those blocks in turn. In terms of easier to use networking, first of all, TCP/IP is no longer an optional install at the beginning of a system install. It just basically comes in, and we've done that both in Windows 2000. It's also in Windows 98. We actually have automatic addressing for LANs in the event that you're on a small network. For example, if you go to a price club and you buy two machines and a hub and you just plug them together and you want those two machines to talk to each other over TCP/IP, we've provided an automatic addressing mode that's very similar to the way IPX and NetBEUI do automatic addressing. And we've radically changed the UI and brought it together for LAN, RAS, and VPN so that, unlike NT4, where you had two different places to look for dial-up and LAN connectivity, you could actually do them in one place. In terms of network administration, as you will note with Windows 2000 in general, there's all new UI based on the MMC, Microsoft Management Console. And we have MMC controls that have been put into the system for RAS, DHCP, DNS, WINS, and a lot of other network-based services, for example, QoS and IPsec. There's new diagnostic capability through the WMI APIs. One of the major changes that we've made in the system, which is important for large-scale deployments, is that because the internet is we've had to work on changing our name system from just a single flat namespace of NetBIOS to the DNS namespace. And so what we've done is we're moving in a migration from purely a WINS-based and NetBIOS broadcast-based naming service to the DNS, which means that we've had to couple DHCP and DNS. This allows our systems now to automatically register in the DNS namespace, and this is a very nice piece of new functionality, basically identifying a transition from a WINS-based infrastructure to a DNS-based infrastructure. And of course, with directory being one of the flagship features of Windows 2000, our policy-based networking for things like IPsec, RAS, and quality of service are basically dependent upon the directory, and we store policy and user preferences and configuration information in the directory. In terms of plug and play and power management, we now have Windows 2000 operating on a laptop, such as the laptop I'm using right now. I mean, it's just great. Your NIC cards and your modem cards, which are the common things that you're going to want to plug and play, are going to do so with Windows 2000. We have dynamic unload and loading of the stacks. We have things such as MediaSense, so that if I have my laptop and I pull my LAN connection out of it, basically it turns that part of the network off, which means that you don't have to have long delays when components are trying to see if they can reach the network. They'll know because of the MediaSense functionality that we've added to NDIS that the network has gone away, which means the system boots faster when it's not plugged into the network, and other applications start up faster because they're not waiting for some server believing that the network is connected. The other thing that we have is we have a new function known as Wake Up on LAN. This allows very large networks to allow their systems to go to sleep or into some kind of standby state, which is a low power draw state of the system, and then a packet coming in from the network can actually bring the system up and wake it up. This allows you to, for example, do backups on systems that are in standby mode over the weekends. But in the meantime, the system's drawing very low power when no one's using the system. In terms of automatic private IP addressing, this is a very important feature to understand in both Windows 2000, and we also shipped an interoperable version of this feature in Windows 98. It's essentially a solution for Soho LANs where you're not running a DHCP server. And what happens is when the system boots up, it looks for a DHCP server, and if it doesn't find a DHCP server, it'll assign itself a network address that is not reachable by the internet. This means that if two systems are on the same network and try to talk to each other, they'll be able to do so. If you ever want to connect to the internet, in all likelihood, you're going to have to put in a box that's either a NAT, a network address translator, or a proxy server that gateways from this private addressed LAN to the internet. Typically, those kinds of functions like the NAT, the network address translator, have DHCP functionality in them, and the end systems on those LANs will discover that DHCP server and get an address from that DHCP server. The private address that it picks is out of the 169.254 Class B address space, which means that you have 65,000 addresses to pick from. It makes sure that it has a unique address by using conflict detection mechanisms, and if you look at your little LAN indicator light, you'll see that it actually probes the network about every 5 minutes to see if it's conflicting with anybody, and if it ever detects a conflict, it will try to reuse the address. The other thing that it's doing is it's probing the network for a DHCP server, so that if, for example, your DHCP server was originally down, you plugged into the network, you got a private address, but subsequently the DHCP service comes up, the end system will discover that DHCP server and get its address from there. This may be a problem on small corporate networks where the DHCP server goes down for a significant period of time. People will start, their end systems will start assigning themselves private IP addresses when they reboot or when a laptop comes back and visits the network. The important thing to remember here is on the network, it still uses NetBIOS naming. So again, the scenario here is typically for a single LAN that has a small number of end systems. We're recommending to customers that if they have a router in their network or if they have a large number of end systems, that they really should be deploying a DHCP server, which of course is available in Windows 2000. And the important thing is again, this whole process of probing the network and looking for DHCP servers when they come online. the features available in 98 and 2000. It's been out there for a couple of years. We've been tuning the algorithms a little bit, but basically the customers are quite satisfied. And our experience is that the ability just to plug two machines into a hub and get connected is quite valuable to end users. In terms of end user UI, we have this thing that's been called the Connections UI. The nice thing for all of you to know is that the network control panel is gone. This has a significant impact for our third-party ISVs, but more importantly, what it does is it eliminates a horrible control panel that a lot of our users filed many complaints on us in terms of NT4. This has been replaced with a single folder where the UI lives for remote access, RAS connectivity, LAN, and VPN, in other words, PPTP connectivity. The look and feel is very similar to what customers learned to like with Windows 95 done dial-up networking. And you can activate and deactivate connections. So for example, you can go click to a connector, basically go to properties by right-clicking, bring up the property sheet, and actually turn off a connection. This allows you to disconnect, for example, from a dial-up connection. You can get through this by going through the control setting, and also you'll see icons in the sys tray for connections, either dial-up, VPN, and also for LAN connections. One of the other things that we've built is a management framework around connectivity, specifically targeted for dial-up, because this is an area where corporate administrators have wanted to download things like phone books for their users so that the user doesn't have to go to a printed sheet and pick up the phone number and determine, okay, this is the phone number I dial when I'm in New York. This is the number that I dial when I'm in Atlanta. This allows the network admin for the network to actually have a phone book server. And every time the dial-up client connects to the corporate network, it checks the phone book server to see if there's a new version of the phone book. And if there is, it will download that phone book to the client system. That way, when the sales guy has traveled, let's say, to Helsinki, he'll already have the Helsinki number for corporate access. It also allows the corporate administrator to pick and choose who's going to provide dial-up access to his users. In the United States, he might want to use one ISP, and when he's in Europe, he might want his users to use another set of ISPs. And so he can pick and choose based on cost or quality of the connectivity that the ISP provides. The other thing is that you can brand and you can customize the UI that the user sees. So for example, one of the things that you might want to do is actually an ISP might want to use the connection manager to customize the dial-up connectivity so that when the user clicks on it, his brand and his sense of the progress of a dial-up connection is presented to his set of end users. The other thing that you can do here is you can also configure VPN connectivity, because in the Windows 2000 model, VPN connectivity is almost identical to dial-up connectivity, especially in the sense of UI. The Connections UI in Windows 2000, again, provides a similar UI. It provides a multi-tab property sheet that allows you to define new properties for each connection, and also allows ISVs to add functionality. And it essentially represents all of the LAN and WAN connections in a single folder. The best way to look at this is essentially to go into the control UI and go down to where you used to see the NCPA, double click on network connections, and boom, you'll see this file folder. This is an example of what that file folder would look like. Basically, we're sitting in here in the UI, and you see the network connections folder. When you bring it up, you'll see a make a new connection, which allows you to make new connections for RAS and dial-up VPN connectivity. And if you have a LAN that was inserted in your system, there should be an icon there for your LAN connection. As I said earlier, the connection manager really simplifies the dial-up process. The important thing to keep in mind is there's the Connections UI, which is end user UI, and there's the Connection Manager, which is designed to allow a network administrator to push down connections to the Windows 2000 clients so that he can essentially centrally manage that dial-up access connectivity. This is to address the problem of very large enterprises and ISPs who had significant difficulties with NT4 and also with Windows 95 and 98 in terms of configuring and managing a large number of end systems. The connection manager, for example, that you see here has a phone book, which you can see on the left-hand side, and there are also additional access numbers that can be represented on the right-hand side. You can also have a custom message that pops up. This might be a reminder that they should be checking some file, or it might actually have a URL that they're supposed to click on when they log in each time. And the nice thing here is that because of the way that remote access works, this phone book manager actually plugs very cleanly into the Connections UI infrastructure. In terms of programmable infrastructure, many of you are familiar with the fact that we built a download from web package known as Steelhead on top of NT4. Essentially, a lot of what we'll be talking about in the next few minutes is essentially taking that Steelhead functionality and the deeper integration that we did with that functionality into the Windows 2000 platform. The primitive functionality that we built into the system here is new routing table functionality with a set of APIs that allow third parties, for example, firewall vendors or network proxy vendors, to take the Windows 2000 platform and build new functionality into the platform so that they can build interesting edge of network devices. The other thing that's happened in the last 3 years is that people are beginning to look at the internet as a bearer network that allows them to layer virtual private networks on top of that bearer network, forming what are known as virtual private networks. And we see virtual private networks in two major forms. One of them is the dial-up VPN, and the other one is essentially branch office to branch office VPN. So let's see what we've done here. For the remote access system, we already had great support for PPP. With NT4 and Windows 95 and 98, we released PPTP, which is our virtual private network protocol technology. And we also have recently been able to release 128-bit encryption. To that, in Windows 2000, we have added EAP, Extensible Authentication Protocol. We've added Radius support that allows us to plug into other authentication infrastructures over and above the Microsoft authentication infrastructure. We've added BACP, which is a bandwidth control protocol. We've also added MD5 authentication, and of course we just talked at length about the connection manager capability. In terms of virtual private networks, in NT4 we released PPTP, and it's also available now on Windows 95 and Windows 98. And this is a comprehensive virtual private network technology. In the last 3 years, there's been a significant amount of standardization in the area of virtual private networking. And since we make every attempt to add value to our customers who want to move to standards-based protocols, we have implemented L2TP, which is essentially, the way I think of it is PPTP version 2, and IPsec. And a lot of you have heard a lot about IP security in the last couple of years, and we now finally have it built into Windows 2000. For Windows 95 and Windows 98, we will continue to be using the PPTP client. In terms of routing, with Steelhead on NT4, you had RIP, OSPF, IPX-RIP, and IPX-SAP for name routing. What we've added in Windows 2000 is the ability to support multicast in our forwarding table. We've added IGMP proxy, which allows dial-up clients to take advantage of multicast networks. And we've added a new capability known as NAT, which is short for Network Address Translation. And we'll talk more about that when we talk about how to interconnect Soho LANs to the internet. And in terms of manageability, we've added SNMP v2 capability. We've built a lot of components that take advantage of the Windows Management Interface, WMI. Of course, for UI, there's a lot of new MMC console snap-ins. And we're now conforming to what we call policy-enabled networking based on the directory. The remote access service, the RAS service, has been around in Windows since NT3.1. And in fact, there was a lot of work done prior to NT3.1. It supports multi-protocol dial access in terms of IP, IPX, and NetBEUI. It supports compression and encryption. In NT4, of course, we added this virtual private network capability and multi-link PPP. And in Windows 2000, We've added a lot of new security functionality, and we've added a lot of standardized IP VPN-based technology, as well as completing the management infrastructure. The big thing that we've heard from customers is, I really love these VPN protocols, but I have 50,000 users I have to manage, and how am I going to do that in a centralized thing? And if I change from one ISP to another, how do I change all the phone numbers on all 50,000 of those clients? And this is what the Connection Manager provides. So it's not enough just to have great protocol support. It's not good enough to have just an improved end client support, but you actually have to address the network manager's problem. That's what we've done with the Connection Manager. The policies are also important, especially for large enterprise deployments of remote access. A lot of people want to control who can access the corporate network through dial-up connectivity or through VPNs over the internet. They also want to control the things like time of day. And so you'll see a lot of new UI in the RAS MMC snap-in for being able to control that kind of functionality. And so what we have is, in a sense, a policy, which is a set of profiles for a user that determines the kind of access that user can have. Remote access policies, and here's an example of what the snap-in looks like. There's actually a point in the tree that's titled Remote Access Policies. It allows you to go in and, on a per-user basis, define what their access policy is. You can also define a generic notion of a policy and assign that to groups of users. And here's an example of what the property sheets look like for this. For example, we can control with the dial-in constraints. We can determine, okay, after how many minutes that this connection has been idle, should we disconnect this? This might be the case where the corporation pays per hour of connectivity, and they might want to control people just dialing up and sitting there doing nothing at length. There's also control of things like multi-link connectivity. So should I be able to bring up 2 ISDN connections to get twice as much bandwidth, but maybe my ISP charges twice as much or 3 times as much? So the network manager may want to control that kind of functionality. There's also an authentication tab that allows you to determine whether they have to authenticate using Microsoft credentials, or maybe they have public key credentials. This whole area of authentication of dial-up users has gotten a little bit more complicated over time, because the customers are basically deploying a variety of authentication technologies. In general, the value proposition of Windows 2000 is that you can use your Microsoft credentials to authenticate, but if you're building a RAS server, they might have a large number of Windows clients, but they may also have Unix or Macintosh clients that don't have the right client software for authenticating to a Microsoft directory structure. In that case, they may need a password-based authentication like PAP, or they might want to use something like a Security Dynamics Smart Card, and we've built in new support into the Windows 2000 platform to allow that kind of authentication to occur on the platform as well. So let's look at the VPN evolution, and this is an important area for our customers. As I said earlier, the internet is now a ubiquitous infrastructure. This means that instead of having to buy an 800 number and pay $5 or $6 an hour to connect back to your corporation if you're a road warrior, it means that anywhere you go in the United States, there's probably a local dial access number that's affiliated with your ISP, and for your $20 to $30 a month that you pay for that connectivity, you can dial up from anywhere inside the United States and take advantage of MSN or AOL or SprintLink or Minecraft or any of the other, excuse me, not Minecraft, MindSpring, any of the large national ISPs. PBTP was an early effort by Microsoft. We've gotten tremendous penetration in the market with that product. We supported it on NT4. The demand for it was so high that we had to go back and build it for Windows 95, and we shipped it in the box with Windows 98 Gold, and it's also now appeared in 2nd edition. It's been implemented by a host of vendors. Pretty much everyone is able to support PBTP today, and it provides a tunneling interface and an encryption interface across the internet for dial connectivity. In 1997, things like PPTP and other protocols kicked off a process of standardization in the internet community. Within the IETF, which is the governing body for standards of the internet, there have been two activities: L2TP, which, as I said earlier, is essentially PPTP version 2 for us, and then IPsec, which is a non-PPP based form of virtual private networks. We've gotten a much broader deployment of tunneling clients in that period of time, and people are beginning to recognize the need of not only providing a great security story and tunneling story, but also some of the other management functions such as auditing, accounting, and eventing. In 1998, we've seen very large deployments. Also in 1999, tremendous market penetration, and the demand for even better encryption and centralized user management, which we have responded to with Windows 2000 with the Connection Manager. In '99, we believe this year is the year of pervasive VPNs. Almost every vendor has a VPN product out there. In many cases, they have more than one. People are also beginning to look at much better authentication technologies in the form of smart cards, and also they're looking at the use of VPNs in the form of consumer devices. Things such as the Windows CE platform are also going to be implementing PPTP type technologies. So our protocol set for this is PPTP, evolving to L2TP, and then using IPsec for really strong encryption and privacy of data on the network. PPP is a mature technology. We've refined it. A lot of people have heard a lot about security problems with PPTP. We've addressed those by fixing the protocols and fixing our implementations. It's been out there. It's been in use for 3 years. It's taking advantage of a lot of experience that we've had with that protocol, and we now support both client to server for roaming dial-up connectivity, but also server to server. In terms of L2TP, we now have the Internet Draft, which is essentially a document going to the standards body, and we're going to be making L2TP available only in, it says here Windows NT 5.0, but all of you know that that's Windows 2000. And in terms of IPsec, this is new functionality. This thing has also gone to, the protocol has gone to the standards body. And what we have done in Windows 2000 is an integration of L2TP and IPsec. We use L2TP to provide tunneling across the network, and we have IPsec to essentially encrypt the traffic. So L2TP leverages the internet as a bearer channel for end-to-end connectivity, and IPsec there is to provide very strong security and authentication between communicating peers. Excuse me. So let's go over the roadmap just to make sure we understand how to position these products with our customers, and so we can help guide others who are looking at this mess of protocols that we have out there. PPTP is out there. We recommend it to all of our customers. It's available in NT4. It's also available in Windows 2000, and we have a complete client solution for the Windows 95 and 98 platforms. In terms of servers, we have multi-protocol support, PPTP and L2TP, in the Windows 2000 RAS server. So when you bring up if the customer is in a situation where they want to migrate from PPTP to L2TP IPsec, the recommendation there is that they deploy a Windows 2000 RAS server or upgrade their current RAS server to the Windows 2000 RAS server, and they'll then be able to serve both clients on that RAS server. For security, for the customers who want additional security capability, we've built a new functionality in terms of the protocols called EAP, Extended Authentication Protocol. This allows us to support smart cards, so that with the smart card support that we have in Windows 2000, you'll also be able to use those smart cards to authenticate to the RAS server over a protocol known as EAP TLS. TLS is Transport Layer Security. It's exactly the same security subsystem that we use in the web. Basically, it's modeled after SSL 3.0. So it's the same kind of security subsystem that we have in terms of the browser talking to web servers for things like e-commerce. So it's a very good security solution. We've added Radius, which allows our RAS server to authenticate against a Radius database, And we've also built into the Windows 2000 platform the ability for Windows 2000 to be a Radius server based on top of the directory. This allows us to play at any point in the network in terms of infrastructure, client, remote access server, and also as a Radius backend. That's important if the customers bought other kinds of remote access servers, let's say a USR, Ascend, or Cisco platform, and they want those modem banks to essentially authenticate via Radius to a Windows 2000 platform. And of course, we support IPsec and something that's known as IKE, which is the Internet Key Exchange, which is the fundamental authentication protocol for IP security. Moving forward, the management framework is also quite important. What we've done there, and like most of the other pieces of management in the platform, we're basing that on top of the Active Directory capability that we have in Windows 2000. And important in terms of capturing end users is essentially continually driving ease of use into the platform so that it's a 1 or 2 click experience, not a 15, 16, 22 click experience to get everything configured and up and running. Server integrated routing allows us to essentially approach those markets like the firewall market, where people want the ability to not only have remote access in terms of traversing from the outside world into their enterprise or business network, but they also want to support some modicum of routing, either in terms of a multi-protocol RIP for IP and IPX or OSPF, a network address translator which allows a private network to be connected to the internet, and also the ability to support multicast. And in many cases, people want to filter protocols. They might not want port 139 for NetBIOS exposed to the internet. So what they can do at that border box that's running Windows 2000, there's actually an API that allows you to go in and say, I don't want port 139 traffic to traverse my gateway. All of this has to, of course, be manageable. The nice thing about MMC is that it provides a single point of management. You can have customized consoles, you can compose consoles, and it also allows our third-party vendors to add value to the platform by adding their own consoles. And in terms of extensibility, we've added APIs for filtering, for quality of service, and that's the traffic control bullet that we have here, and we also have new driver APIs in Endis to support new kinds of network functionality. The routing architecture that we'll go through very quickly here is one that continues to be based on the Endis interfaces, so that the hardware still are the same pieces of hardware that you use for host access. We have an IP and an IPX forwarder for taking packets from one interface and pushing them to another interface. We also have API structures that allow you to manage the routing table for either an IPX or an IP forwarder. And also we have interfaces that allow people to write routing protocols on top of all of this. For example, today we have unicast routing protocols. We also have a management plane that supports SNMP and other management applications that might come in through WMI to pick up things like performance counters, errored packet counters, misrouted packet counters. And of course, over the course of the Windows 2000 project, we've also added new capabilities in the form of a multicast forwarder, which will allow multicast group managers to take routing information from multicast routing protocols. The feature summary here is straightforward. We support most of the unicast protocols. We believe in general that Windows 2000 should be able to plug into most standards-based routed networks that are out there, whether they're routed with RIP or OSPF, and also IPX. We support multicast forwarding, proxy, and the routing APIs. Of course, it's not only a routing platform, but it also supports remote access and VPN all in the same infrastructure, and you can get to that through the RAS UI. One of the newest features is this thing called network address translation, and we also have APIs for extending network address translation and routing, and also the management capabilities in the platform. Packet filtering is something that we added in Service Pack 2 of NT4. There are several platforms that take advantage of that now, and we've enhanced that packet filtering capability and have exposed that as an API. This extends the Trojan filter capability that we had in NT4.0 to one that's per interface and can filter both TCP and UDP connectivity, and can do this at a very high performance level that can also be hardware accelerated. So one of the problems that a lot of our customers face today is, I've got a small network, I've got 10 people in an office, and I want to give them the power of the internet to their desktop. And I can, today when you walk into a lot of these small offices, they have 10 disparate machines, they all have their own modem, and they all dial up to some ISP. And in many cases in the same business, they dial up to different ISPs for people to get their email, for example, or to surf the web. What we've done with Windows 2000 is we want to make it possible for people to go off and buy a small hub, drop it into the network, and basically interconnect those set of PCs that are interconnected with that hub to the internet, all using Windows-based technology. And so the whole goal here is to essentially bring the power of the internet to the small office environment. SOHO is short for small office and home office environment. A lot of people also call this home networking, because it's in the case where I go home and I want to have 3 or 4 PCs for my kids and my wife all being able to access the internet at the same time. We're also able to do that using this new capability in Windows 2000. The idea here is that you'll have a Windows machine that dials up to the internet using modem or ADSL or cable modem connectivity, and there will also be a LAN adapter on that Windows machine that's connected to this hub, and then all the other machines are connected to this hub. It doesn't necessarily have to be a hub. It could be something like a home LAN, for example, phone wire network or a wireless network. One of the goals here also is to make this a one-click or a two-click experience for the person who's setting this up. If someone has to learn everything about setting up a network, they won't do it. It's a barrier to entry for these small networks. So the goal here is to make it as simple as taking a machine that has a single LAN adapter and a modem, and being able to go to the connections UI for that modem connection, go to the property tab, click on sharing, and essentially bring this up. So what are the components to our connection sharing solution? We have something called network address translation. This is the thing that allows that single IP address to be shared by all the machines that are going through that machine to the internet. That has a DHCP server running in that one machine that gives out an IP address, a private IP address, to all the machines on the network. It also provides a DNS proxy, which means that when a machine on the subnetwork wants to resolve a name like foo.bar.com, that DNS query goes up into this system, and it talks to the DNS server that it learned about from connecting to the internet. We also support an auto-dial connectivity model, whereby when a client wants to access the internet and your interconnection machine, or your internet connection sharing machine, isn't currently connected to the network through its dial-up connection, the packet coming from the client machine actually causes that internet connection sharing machine to then dial up to the network using the auto dial capability. The other thing that's really important is to support our VPN technology over this internet connection sharing capability. So if I come home with my laptop, plug it into my home network, I'm going to want my internet connection sharing machine to allow me to do PPTP back to my corporate network, so that I can connect to my corporate exchange server and I can do my work, I can browse the internal CorpNet web, things of that sort. And so it's one of the important things about our NAT solution, or our internet connection sharing solution, is that it allows PPTP to traverse over that technology. As we mentioned, this is a single-click solution. You essentially go to the dial-up property page on that connection. You look for the tab that says connection sharing or shared access on that tab. If you click on the Shared Access tab, that promotes it to the front, and you can see that there's a single dialog box that you have to click. If you click Enable Shared Access for the connection, in other words, turn on internet connection sharing, that means that machine now will gateway between its LAN adapter and its dial-up adapter. This also can be supported on a 2 LAN connected machine. So if I have a laptop that has 2 LAN adapters in it, or if I have a desktop with 2 LAN adapters, I can also go to that Connections UI, bring up the property page, and go to Shared Access, and basically turn on one side to be for the public internet, and the other side, the other LAN adapter, to be for my private network, which is my home network. If you click on that Enable Access, it'll also turn on the ability to turn on auto dial. So essentially, it's either a one-click solution if you're always going to be turned on, for example, 2 LAN adapters, or if you want to use the auto dial capability, it's essentially a 2-click solution. In terms of manageability, we've already talked about some of the new MMC UI. There's policy management for a lot of components in the system. We have a significant amount of policy management that's been installed in the system for quality of service. This allows a network administrator to deploy something that's called the admission control services. And so if somebody wants to limit the amount of NetShow traffic, let's say he has a huge farm of NetShow servers, and if they were all to pound multiple movies into the network would fall apart. He can actually deploy an admission control server and set up policy for those servers so that in the aggregate that farm could only insert, let's say, 30 kilobits or 100 kilobits or 500 kilobits a second. And if anyone ever tried to insert, let's say, 10 megabits a second into the network, the application would know that it wasn't allowed to do so and it would shut itself down. This allows us to specify policy on a per user and also on a per subnet basis. We also have new MMC UI for IP security management using the Active Directory. And an important upgrade that we've had in the system is we've moved the management framework from SNMP v1 to SNMP v2. In terms of communications enhancements, we've significantly improved the stack so that we believe we can now drive gigabit adapters in Windows 2000 boxes. This is a significant improvement in aggregate network performance, and we've measured this in the lab, and the Perf Lab continues to make great advances in terms of not only handling a single gigabit adapter, but multiple gigabit adapters in a single machine. We've also added large window support to TCP and selective acknowledgements, which are designed to improve the performance of the system. Window support is to improve the performance of the system over what are known as high bandwidth delay pipes, and selective acknowledgement is to allow TCP to do a better job of recovering from packet loss, which happens quite a bit in the internet. We also have much better round-trip time estimators, and this just allows the TCP/IP stack to do a better job of determining how fast to insert traffic into the network, and it subsequently improves the throughput of our systems. And we've also been working on the scaling of our TCP/IP stack to support multiprocessors, 4-way and 8-way NT-based systems. Of course, we've added IPsec and we've added quality of service. Our quality of service program is fairly extensive in that we've added new APIs to the system on the WinSock 2.0 API. We've added a traffic control API, which allows a management application, for example, something driven by OpenView or Tivoli or SMS, to actually control the aggregate behavior of the quality of service. We also have the ability to mark packets so that when a system sends a packet into the network, a downstream router can look at the marking on the packet and say, this packet is high priority, this packet is low priority, and give preferential treatment to the high priority packets. And also, we've just talked about the admission control service, which allows a network administrator to provide resource management of the network. Our IPsec solution is fairly comprehensive in the sense that we support both transport mode and tunnel mode of IP security. It provides for end-to-end privacy and integrity, which means that the packet can't be modified in flight, and authenticity, because there's very strong authentication between two communicating peers. If somebody tries to spoof a packet by either inserting a new packet or modifying a packet in flight, the receiving end system will be able to determine whether that spoof is occurring. We did some collaborative work with Cisco to develop our IKE capability. We can do authentication of the two peers that are communicating with each other, either with Kerberos, which will be the native deployed authentication infrastructure with Windows 2000, or we also have the ability to allow two systems to authenticate each other using public key technology and certificates. One of the big problems that people have with IPsec is how do they manage policy? If for example, they want to only allow a certain set of users to access a file server, how can they basically specify for a group of users in a simple manner how to get that kind of policy into those end systems? The way that we do that is taking advantage of the directory, and I'll show you how that works. One of the nice things about IPsec is it's layered very low in the stack so that essentially everything above it should not know that IPsec is turned on. So applications don't need to change. You don't have to go off and get a whole new set of IPsec capable apps to take advantage of the IPsec functionality. The components for this system are fairly straightforward. We have essentially the directory, which is the triangle above, which maintains user policy and also will contain certificates that can be pulled down. We have an IPsec driver, which is basically responsible for making sure that the traffic that flows through the system is encrypted and sent over to its peer. Before any traffic can happen between two communicating peers, the IKE protocol basically runs to do a key exchange and generation in a secure manner. And those two peers essentially at that point in time authenticate each other. They generate a session key. The session keys are then plumbed down into the respective IPsec filters, and then all traffic going through those filters is appropriately encrypted and also protected with an integrity checksum. As I indicated earlier, this takes advantage of not only certificates, but also takes advantage of the native Kerberos authentication. So you do not have to roll out public key infrastructure in an enterprise unless you really want to. Our quality of service program basically addresses the issue that network managers want to control their network resources. They want to basically preferentially allow traffic to go through for their mission critical apps, and they also want to deploy next generation applications that provide things like streaming media. There are many things that have to happen to provide quality of service in the network. Essentially, the hosts have to be upgraded to supply marking of packets and signaling. The routers in the network that interconnect into the ISPs have to be upgraded in terms of either software load or in hardware to provide for quality checking and metering and matching and policy control. Many enterprises are going to upgrade their Ethernet infrastructures, their switches, to provide 802.1p capability. The importance of the 802.1p capability is that our end systems are not only going to be able to mark the IP packet, but they'll also be able to mark the Ethernet packet, so that when that Ethernet frame gets to an Ethernet switch, it'll be marked high or low priority. And so, for example, voice will be marked as high priority, and this is the thing that will allow IP telephony to get deployed en masse in enterprise networks. And also, ISPs are beginning to do trials with preferential services. So they might offer what are often known as Olympic scale services: gold, silver, bronze. Gold traffic is the traffic that you want to get there and that has a 0% probability of getting dropped. Silver, you might get dropped 0.01% of the time, and the rest of your traffic goes along the bronze service, which may get dropped, hopefully less than 1 or 2% of the time. And for things like your mission critical apps, you might elect to use the silver or gold bands, and in all likelihood for things like voice over IP traffic going over an ISP cloud, you'll want to use the gold band. We have a new API, as we mentioned before. There's extensive changes in the stack. There's actually a separate install for something called psked that customers will have to do on their end systems if they want to enable the QoS service on their systems. If they want to do this resource management for things like streaming media, we have this admission control service that implements a protocol known as the Subnet Bandwidth Manager, SBM. but it will show up in the services as admission control service. And this is work that we've done collaboratively with Intel, Cisco, 3Com, and other network vendors, and it's been standardized in the IETF, and takes advantage of a protocol known as RSVP, which is a bandwidth reservation protocol. This notion of network resource management, also we've exposed other APIs on a per end system basis, which actually allows a network administrator to run scripts, for example, perhaps at login or when the system boots up, that could say things like, I never want my email traffic to take more than 1 megabit per second, or all FTP traffic going out of the system can't take any more than an aggregate of, let's say, 30 megabits a second. These are the kinds of capabilities that are exposed through the Traffic Control API. Our QoS networking program has several components in it, and I'll go through these very quickly. Essentially what we're doing here is we have two applications running on the end system. We have a net meeting session, which is running audio, and FTP that's doing data transfer. Essentially what's happening here is that there's a component in the stack called Traffic Control that takes the net meeting packets and reschedules the packets so that if a net meeting packet and an FTP packet are in the queue at the same time, waiting to be transmitted on the network, the traffic control filter in the stack will actually promote the net meeting packet in front of the FTP packet. The other thing that's happening is that we have an RSVP signaling channel that's going between the two communicating end systems, and we can actually take advantage of our SBM, or our admission control service, to look at that signaling on the network and determine whether it matches the policy that's been recorded for that user in the directory, which is symbolized by the arrow between the subnet bandwidth manager and the DS. And we also have the ability to prioritize the traffic, not only in our own traffic control elements, but when those packets hit things like routers connected to ISPs, those routers will look at the packet marking that we have going on in the system to determine downstream preferential handling of traffic as well. The WinSock API has been modified. We've done an extensive amount of performance improvement in WinSock 2 as well. This API is also now available on Windows 98, so that ISVs can write to these quality of service APIs both on the Windows 98 and the Windows 2000 platforms. The QoS architecture is fairly straightforward. We have WinSock 2 as an API. We have a packet classifier and scheduler on the bottom of the system. In the previous slide, that was drawn as a triangle to basically, when any component puts packets into the stack, the packet classifier looks at the packet and determines what priority queue it belongs into, what rate it's allowed to emit those packets into the network adapter, and basically appropriately schedules those packets using the packet scheduler. A lot of people have asked us about IP version 6. The important message there is that we do not have an IP version 6 in our product in Windows 2000 or in Windows 98. Microsoft Research has built an IP version stack, a version 6 stack, and it's distributed as source code with a license that allows people to use it for research and development. We've had very few customers ask us for IPv6 deployable software, but a lot of people are preparing for the next 2 or 3 years, where they see in the years, let's say 2002, 2003, where they'll start converting their infrastructure to support IPv6, and they'll want to start seeing how Windows applications work on top of that IPv6 infrastructure. We do have product plans for IPv6 in development, and news will become available as we have a much more concrete plan for that technology. Why would people want to do IPv6? Well, we see the biggest use of IPv6 is in the form of consumer networking for billions of small devices. Essentially, the IP address space is really only big enough to support 2 to the 32nd devices, about 4 billion of them. So we can actually do 4 billion PCs, which is quite a few PCs. And also with technologies like NAT, you're actually able to hide the fact that you have several other PCs behind a single PC. IPv6 is an important technology. It's being vetted right now. Some of the protocols are being standardized, are going into final form of standardization now, and this is going to be a significant amount of work for us in our post-Windows 2000 systems. I'd like to finish up today talking about TAPI 3.0. TAPI provides the ability for us to talk about both classic PSTN and IP telephony infrastructures and protocols. And the other important upgrade from TAPI 2.1 to TAPI 3.0 is that TAPI 3.0 also now supports COM. So we have a unified call control for both classic telephony and IP telephony. We take advantage of COM. It's integrated into the Active Directory. We do that basically by putting things like conferences and the location of users into the directory or into ADSI API available infrastructures. The protocols that we support for IP telephony include H323, and we also now have the ability to support something known as IP multicast audio and video. This is important to provide scalable video in enterprise networks. If you want to have, let's say, a conference with 4 or 5 people where you essentially want to have 4 or 5 talking heads, it's much more efficient to take advantage of IP multicast for that video distribution, and we have that ability now in Windows 2000. This is a revolutionary technology. A lot of you have heard of things like the M-Bone, and what we're doing is we're taking advantage of that multicast technology, and we've deeply integrated it under TAPI 3.0, and you'll see other products layered on top of TAPI 3.0 that take advantage of IP audio and video multicasting. The other thing is that these technologies that we've built also enable building telephony servers, and there's a whole raft of activity where people are trying to do integrations of PBXs, LAN PBXs, and IP telephony capabilities. The application scenarios for this are IP to PSTN bridges, LAN PBXs, firewalls that allow you to traverse net meeting to net meeting across corporations, and there's capabilities like that that are built on top of NAT and the IP telephony capabilities in the system. We've extended TAPI 3.0 consistent with our original TAPI 2.x infrastructure. So we've tried to create a model where our existing driver model for voice, data, and fax can be extended into this new world of IP telephony. The other thing is that as the carriers roll out services like ISDN and ATM and frame relay, we've added new driver models in the form of NDIS-5 to support that. I've talked a little bit already about how our IP telephony solutions depend on being able to have the network as a source and sink, and that's been exposed to our users using the TAPI 3.0 APIs. And the WDM streaming here is essentially talks to the ability to layer a streaming module underneath a proxy underneath the TAPI 3.0 API. So what this basically allows us to do is to build a direct show based application that talks to a WDM streaming module that then talks to an adapter such as a PRI or an ATM adapter in the system. This is important for us to be able to build things like voicemail systems on top of either ATM or PRI connectivity. In summary, our key investments have been in ease of use and manageability. We have a whole host of new APIs and services in the system, and this is to enhance not only networking but also telephony, and hopefully in the area of converged networks where we want multimedia streaming to run on top of IP over LANs and enterprise and also ISPs. We have a very strong commitment to standards. We work extensively inside of the IETF and in W3C for web-based standards. An example of that is what we're doing with Kerberos, what we're doing with Radius, what we're doing with RSVP, the performance extensions to TCP/IP that we've created, the security solutions such as TLS, IPsec, our directory protocols such as LDAP. And of course, we're conforming to ITU standards for our H323 voice over IP standards. And it's important to remember that with Windows 2000, we're not only trying to build the ability to have a voice conference in there, but we're trying to create the opportunity for our third-party partners, not only ISVs but also IHVs, to build on top of our platform using our driver models and in using our APIs to build new features on top of Windows 2000. If we don't build it into the platform, we've built the right APIs and driver models into the system to allow this to actually be this new functionality to be created out there in the market by other businesses as well. And we believe that we have the perfect platform for people to build new firewall, private virtual network, policy-based network management functionality moving forward. I'd like to thank you very much for your time today. Ran a little bit over our hour. I hope this was useful, and you should look at some of the other talks on networking to get a much deeper technical drill down on these subjects. Thank you very much.